Okay, so let's use the inverse trig functions in practice now in some word problems. So 2 legs of a right triangle have the length 17 meters and 25. Solve the whole triangle. Okay, so the first thing we're going to do is draw. It's a right triangle. It's called ABC. So that means this is side A, side B, side C, because it's opposite from the angle. And, well, I could actually go back and say that these two sides are going to be 17 meters and 25 meters. Okay, so what we don't have is our length for B. So that's the first thing I would solve for. And since it is a right triangle, we can use Pythagorean's theorem. So B equals 17 squared plus 25 squared, and then we take the square root of that, and we get about 30.2 meters. Okay, so now we need to find our angles. So let's start with angle A. So to find angle A, there's a couple of things we can use. I'm going to stick with the 25 and 17 we were originally given. So for angle A, we have tangent of that angle we know equals 25 over 17 because it's opposite over adjacent. But to find A, we are going to use the inverse function. So that would look like this. Tangent inverse of 25 over 17, and we get about 55.8 degrees. And then we're going to do, we could do the same thing if we wanted to. You could use a trig function for angle B, but the easiest thing to do, since we have two angles, so to find angle C is to take 180 and subtract 90 and subtract our new 55.8, and we get about 34.2 degrees. Okay, number 2. From 1976 until 2010, the tallest freestanding structure in the world was the 553-meter CN Tower in Toronto, Ontario. Suppose that at a certain time of day, it casts a shadow of 1,100 meters along the ground. What is the angle of elevation of the sun of that time of day? So we're just going to say, okay, here's my tower. All right, so here's my shadow. We're going to pretend like the sun is up here, my purple sun. So this tower is 553 meters. And we know that the shadow is 1,100 meters long. And it wants to know the angle of elevation from the ground. So that means that this right here is our theta, our angle of elevation. So we're going to solve just for that. And to do that, we have to use tangent because we're only given opposite over adjacent when regards to this angle. So tangent of this angle, theta, is opposite over adjacent. So to find the actual value of that angle, we're going to use tangent inverse. And we get about 26.7 degrees. So this is our angle of elevation. Okay, the last one here. So a photographer is taking pictures of a 150-foot tall roller coaster. Okay, so I'll do the best I can. Draw my roller coaster. Okay, so I have a 150-foot roller coaster. She sets her camera up. Oh, I made this a little too far over to the right. All right, so we have the camera, and it's 3 feet above the ground, and she's going to take 2 pictures. So the camera is going to be right here, which we know is 3 feet above the ground. All right, so the angle of elevation, so she says the first picture is taken from 300 feet away. So we know that this is 300. And obviously this is not drawn to scale. And she's looking at the top of the roller coaster. So she's looking all the way up here. So it wants to find the angle of what the camera is aimed on. So our first angle is right here. So to find this, we need to first, well, we note that we have opposite and adjacent, but instead of using 150, we actually want to use 147 because the camera's 3 feet off the ground. So tangent, and we're going to do inverse since we're trying to find the angle. So the opposite is 147 over 300, which is our adjacent. So when we do this, we get 26.10 degrees. So this is the first answer. Then it says that she takes her second picture from 200 feet away. So now the camera's here. We're at 200. It's still 3 feet off, and it's looking at, no, it says it's 2/3 of the way up. So we now know that we're still going to use tangent, but, all right, so here we go. So tangent of -1. So here's the but. The opposite isn't 147 anymore, and it's not 150. It's 2/3 of the way up the roller coaster. Well, the top of the roller coaster is 150, so 2/3 of 150 is going to be 100. However, the camera is 3 feet above the ground, so we actually have 97 feet here in blue. This is 97. So that's our opposite, and our adjacent is 200. And when we figure this one out, this angle of elevation is 25.87. So the first shot is actually is steeper. Now, it's important to know that you might think, well, if I get closer, it's going to get steeper, so that doesn't make sense. But the reason why it's not that way in this case is because she's not looking at the top anymore. She changed where she was looking. So that's why we're actually a little bit more steep on the first angle.